A man was found dead in a market in Sylhet. A schoolgirl died in the football field in the sports day under the burning sun. Why is this happening? Heat stroke, a life-threatening heat illness that most of us don't know about. Assalamu alaikum, I am Fahad Ahmed Ruhan and my team is presenting Heatstroke Prediction in Bangladesh based on WBGT Index and machine learning approach, and we are going to implement it in a mobile application. So the motivation behind this work is that the death rate due to heat stroke is rising very rapidly day by day in the world and also in Bangladesh. And most of us don't even know about it. People think that it's normal heart attack or any other disease, but it's heat stroke. And you can predict heat stroke, but you need expensive WBGT devices, which may cost somewhere around $1,000 to $3,000. And it's not convenient for personal use also. And we researched and found out that there is no existing tech-based prediction system on WBGT. There exists an application on heat index, but heat index doesn't work with sun, so we have to work with WBGT. And there is also no study based on Bangladesh in this particular field, so we try to solve this problem. And our objective first is to predict the wet bulb globe temperature index using machine learning algorithms. So what is wet bulb globe temperature? It's one kind of index that's going to indicate the risk of heat stroke. It's different than the normal air temperature because the WBGT or wet bulb globe temperature, it works with all of them like air temperature, humidity, and also wind speed. And then our plan is to plan was to use widely available meteorological data because in the actual WBGT it uses data like variables like wet bulb temperature and globe temperature, and normal people can't get access to these two variables. So we had to replace them with widely available data like normal air temperature, wind speed, and relative humidity. Then our ultimate goal is to replace those expensive WBGT device with a mobile application so that each individual can use it and save them from heat stroke. Now I'll request my teammate Istiaque to continue the literature review and methodology part of our work.
Thank you, Rohan. Good afternoon and assalamu alaikum everyone. I'm Istiaque Khalique. Now I will present the literature review on the next slides of our team. Well, so far we have reviewed 14 papers relevant to heat stroke, and we have found that in 6 of the papers they have employed in 3 of the papers they have employed linear regression technique, and random forest in 4 papers, and one paper employed decision tree and another paper employed KNN technique. Well, for WBGT and DG, we have used their formula obtained from 2 different papers, and their formula is cited in the literature review. You can see in the left section of the slide. Here WBGT, the formula used wet bulb globe temperature, then TG, then TA, which stands for air temperature, and for TG calculation we have used the average solar radiation obtained from a paper of QUET, and then there are air temperature and relative humidity. We have used the average solar radiation obtained from the a paper the QUET, and well, the main gap was in this field was that there was no existing study in WBGT prediction in the subcontinent, specifically in Bangladesh system, and eventually there was no heat stroke level danger-wise WBGT level danger-wise prediction system. And in the right side of the slide you can see our methodology section. We have collected our available meteorological data as air temperature, relative humidity, and solar radiation from the NASA Power website, and after that we have pre-processed the data. So what we have pre-processed? Well, there was no TG and WBGT publicly available, so we have calculated the value of TG and WBGT by using the formula mentioned in the left side of the slide in literature review section. After that, our target was to predict WBGT in the daytime, so we have dropped the nighttime data, and for feature selection we have considered 3 input features: air temperature, wind speed, and relative humidity, and target variable WBGT. And we have distributed our data set into 3: training, validation, and test set. For training we have used 70% and 10% and 20% for validation and test set respectively, and we have trained 4 classical ML regression models, and for performing their analysis, for performance evaluation of these models, we have used R2 score, and we have also further assessed the models using a 10-fold cross validation technique, and finalized our result into an app, and that it mentioned the workings of app procedure. So on next slide. And in this slide, moving to the next slide, you can see we have created a bar chart of the 4 ML models, and they are R2 score comparison and error matrix comparison. And if you observe carefully, you can see that random forest has obtained an highest R2 score in both the test and validation set, which is about 99.997%, and in the error matrix comparison, linear regression obtained the highest quantity of error in four categories, namely three categories, sorry, mean absolute error, mean absolute percentage error, and root mean square error, whereas random forest has the lowest amount of error in these three metrics. And in the right side of this slide, you can we have plotted a random scatter plot of random forest, and its score performance evaluation scores as R2 score, which is 99.997% of the test data set, then mean absolute percentage error of 0.05, then mean absolute error of 1.10, and root mean square error of 2.44%. And we have selected random forest as the best model for our among the four other models, because it outperform all the other models in case of R2 score and error matrix comparison. That is from my side, and the next slide will I would like to invite my team, Fahad, Ahmed, Ruhan, to present the next slide.
Thank you, Istiaque. So here is our implemented app overview. So on the left side, you can see the graphical view, which consists of our features and the pages of our app. So if you use this app, how you are going to predict WBGT? So the app is going to give you real-time data based on the API-fetched weather variables like humidity relative, humidity, wind speed, and air temperature. And you can get your danger level based on this WBGT. Like if you can see on the right side, the second figure shows that it's a normal day and the WBGT risk is normal, so you are good to go. And if you see in the third figure, you can see that the WBGT is over 31 degrees Celsius, which is on the danger category. So if you click on the precaution feature, you can see what to do and to save yourself from this risk of heat stroke. And we have collected these risk levels from a paper based on Thailand and also the Osho Japan website. Thank you for listening to us. Any question, please?
Okay, thank you very much for your nice presentation.
Welcome.
So you implemented it. It is a hardware implementation, I mean.
It's a software implementation.
So, software implementation. So how you have to put your finger somewhere else?
No, you don't need any physical data. It's gonna work with meteorological data. So it's gonna fetch data from the Open Weather Map API, and then it's gonna give. It's gonna work like a weather app. Just you are gonna get the extra feature of WBGT, which will be coming from our machine learning model.
Okay, thank you.
Any more questions?